Welcome back at C squared. In this lesson we're going to talk about linear equation, and I said here a linear equation is an equation whose graph is a line. And you notice here on the left side I have 5 examples. All these equations represent the graphs are represented by lines. On the other hand, this one are what we call non-linear equation. The graphs are not line, and if you notice here the difference between these two, we have power, we have product, we have square root, we have here x as an exponent, how we call, and here x is the denominator of this quotient. And these are some example of non-linear equation. Linear equation, you notice they have only x and y, no powers, no radical, no product, no exponents, variable as exponents. These are linear equation whose graph are lines. And I said here you can graph a linear equation using a table. So let's take a look on this example here where I said graph y equals x plus 2, and I'm going to use a table. You can use a vertical or a horizontal table. In this table I'm going to put x and y. You choose your value if that is possible, in other words if it's not restricted, and in this case we have no restriction. So I'm gonna use the following value. I'm gonna start with 0. When x is 0, y will be 0 plus 2, which is nothing else than 2. That's the value. I'm gonna put it down in the table here. I'm gonna go to 1, the next one, and I'm gonna do the same process. X equals 1, and I have y equals 1 plus 2, which is 3. And I'm going to put 2 here, and similar I'm going to get x equals 2, y equals 2 plus 2, which is 4. And that goes in the table. And I'm going to get 2 negative value, negative 1. And we get y equals negative 1 plus 2, which is 1. And we get, I'm going to get obviously negative 2. And we have y equals negative 2 plus 2, which is 0. We have enough information to graph this equation, and I'm going to start with this one, 0 and 2, which means I'm going to move 2 up and stay here. 1 and 3, this is the second point, this one. 2 and 4, which is going to be right here. And you already notice these 3 points are on a line, but let's put the other two, negative 1 and 1, which is right here. Go 1 left, 1 up, and negative 2 and 0, which is right here. So now we do have a good idea how the graph looks like. You notice I go through these points. Okay, and you want to put an arrow. This is the graph of y equals x plus 2 using a table. Let's move to a second example, very similar. We have y equals 2x minus 3, a table. Let me redo this table. And we have x, y, and I'm going to put negative 1, 0, and 1. You notice I put only 3 values instead of 5 like in the other one. And let's take a look what's happened when x equals negative 1. We have y equals 2 times negative 1 minus 3, and that will be 2 times negative 1, negative 2 minus 3. That will be negative 5. And you can really put a point if that works for you. It doesn't work for me. 1 left, 5 down, I don't have enough space, so I'm gonna move to the next one. X equals 0, and I'm gonna get y equals 2 times 0 minus 3. 2 times 0 is 0, minus 3 is gonna be negative 3. So this point is 0 and negative 3, so I'm gonna go 3 down from the origin, and that's the point. Let's get to the next one. X equals 1, and we have y equals 2 times 1 minus 3, which means 2 times 1 is 2, minus 3 is negative 1, which is going to be 1 right, 1 down, right here. And let's take another value. Let's take 2, the next value in the table, and we have x equals 2, we have y equals 2 times 2, minus 3. 2 times 2 is 4, minus 3, and that will be positive 1. And we have 2 and 1, which is right here. And you notice these 3 points are on the same line. That's the reason you want to use at least 3 points. You want to be sure your graph is correct. The third point is for checking. For graphing a line, in fact, you need only 2 points. The third one is for checking. But here you see I have 4 values, and sometimes you may need that. My next example will contain a fraction 1 over 3, and whenever you have something like this, it's very important to know how to approach if you want to use this technique, a table. And you will notice here I'm going to start with 0 like in the previous example, but the next one is going to be 3, and the next one can be 6. I will put 6 here even though I do not have enough space here to graph it, and probably I'm going to put negative 3. So I think with this 4 value I can get a good graph. So let's start with the first one. X equals negative 3. We get y equals 1 over 3 times negative 3 minus 2. 1 over 3 times negative 3, that is negative 1, minus 2, that will be negative 3. So I'm going to have negative 3 here, which means I'm going to go 3 left, 3 down. Right here is the first point. X equals 0, y equals 1 over 3 times 0 minus 2. 1 over 3 times 0 is 0, minus 2 is negative 2. So 0 and negative 2, which is right here. Let me put this in the table. X equals 3, the next value. So we have y equals 1 over 3 times 3 minus 2. 1 over 3 times 3 is 1, minus 2 is negative 1. So 3 and negative 1. So that means I'm going to go 3 right and 1 down. And you notice these 3 points are on the same line. I don't need the fourth one, but let's do the math. X equals 6 equals 1 over 3 times 6 minus 2. So 1 over 3 times 6 is 2. Minus 2, that will be 0. But like I said, I cannot plot that point. But with these 3 points, I can graph this line. Okay, and this is the graph of y equals 1 over 3 x minus 2. And you notice how I pick the value. I pick multiple of this denominator. That's the best way to handle this type of graphs if you use this table method. Another one very similar, and by now I think you know what we're gonna use. X, y, and I'm gonna do negative 3, 0, 3, and maybe 6. We'll see it. Maybe we need it, maybe we don't need it. So again, we're gonna start with x equals negative 3, then we have y equals negative 2 over 3 times negative 3. use a parenthesis here, plus 1. Negative 2/3 times negative 3, that will be a positive 2. Okay, to this you can do this one like this, these 3 cancel out, and negative cancel out, you have only a 2 left. 2 plus 1, that will be 3. So negative 3 and 3, so go 3 left, 3 up, we do have enough space, the point is right here. And let's go to the next one. X equals 0, we have y equals negative 2 over 3 times 0 plus 1. Similar to the previous example, this is negative 2/3 times 0 is 0 plus 1. That is 1. So I have the point 0 and 1, which is right here. Now we're going to go to the next value, x equals 3, and we have y equals negative 2 over 3 times 3 plus 1. Again, here you can approach like this, cancel out these 2 3's, and you have negative 2 left, plus 1, that will be negative 1. And we have the point 3 and negative 1. We don't need the last one, but since I have it in the table, let's find the value. Y equals negative 2/3 times 6 plus 1. Similar, we can do 3 goes in 6 2 times, and we have negative 2 times 2, that is negative 4 plus 1. That will be negative 3. But like I said, we have no way to plot this 0.6 and negative 3 on my graph. So now let me see if I can connect these 3 points. They all should be on a line, which I hope I can draw it. There you go. And this is the graph. This is the graph of y equal negative 2 over 3x plus 1. Let's take a look to an example like this. You see it's a little bit different than the others. We have not y equal. We have this form, 2x plus 3y equals 12. But we can do the same thing. We can make a table. X and y. And we can pick 0. Let's see what we get. X equals 0. And we have 2 times 0 plus 3 times y equals 12. And that will be 0 here plus 3y equals 12, which gives me only 3y equals 12. Divide by 3 and we get y equals 4. So I'm going to have 0 and 4, which is right here. Okay, let's try 1 to see what's going on. And if we have x equals 1, very similar, we have 2 times 1 plus 3y equals 12. And this one is going to be 2, right? 2 times 1 is 2 plus 3y equals 12. If we subtract 2 on both sides, we end up with 3y equals 10, and we get an y of 10 over 3, which is not very nice to be plot in this case. So we need another value that will help us to sketch the graph of this guy. And we can have another way to approach the problem. Here we can make the y 0. I'm going to write that here, y equal 0, and we can put in the table here if you want. Really does not matter if they are not in order. So you can pick a value for y, and let's see what we get. 2x plus 3 times 0 equals 12. We have left only 2x here because 3 times 0 is 0 equals 12. And if we want to solve for x, divide by 2, we have x equal 6. So we have this point 6 and 0, which unfortunately it's somewhere on the right side. We cannot really use that point, but I guess I can go and use another value of 3 for x. Let's see what's going on with 3. And we have x equals 3 is going to give us 2 times 3 plus 3y equals 12. That will be 6 plus 3y equals 12. If we subtract 6 on both sides, we end up with 3y equals 6, and then divide by 3y equals 2. So I think from all these points, I'm going to use only this one, and I already use 0 and 4. 3 and 2 is right here. And like I said, you really don't need more than 2 points if your math is correct. The third one is for checking. So in this case, I'm going to use only these 2. This is the graph of y equals 2x plus 3y. I will say also, you notice these 3 here. Okay, you can use multiple of 3, 6, or negative 3. That will be an easy way to remember if you want to approach the graph using this method. A very similar one. X and y. And I'm gonna use 0, and if you remember, I said look to this guy and you can pick the next one as 2, then the 4. That will be another good. A negative 2 will be good. And let's start with this x equals 0, see what's going on. X equals 0, we have 0 minus 2y equals 8. So we have left only negative 2y equals 8. Divide by negative 2, we get y equals negative 4. So we'll take a look, and that guys is right here. We can plot it, so it's a usable point. Let's go to 2 and see what's going on. We have 2 minus 2y equals 8. I will subtract 2 on both sides, and we have negative 2y equals 6. Divide by 2, by negative 2, I apologize, and we get negative 3. 2 and negative 3, which is right here. And we have the graph, a very good graph for us. We can move to 4 if you want. I think we're gonna get this value. You may want to check it. 4 and negative 2, check it. For negative 2, we're gonna get probably negative 5, which I cannot plot it. Again, you may want to check it. I want to do something else here. If you remember, I want to get 0 for y. So I'm going to put it right here, because we can use this technique. Sometimes it's very helpful. Y equals 0. We end up with x minus 2 times 0 equals 8. 2 times 0 is 0, so we have x equals 8. So we have the point 8 and 0, which unfortunately we cannot plot it, but sometimes you can use that value, and that will be very useful. This is the graph of this equation, x minus 2y equals 8. On the last part of the lesson, I just mentioned something that is very useful. The last 2 examples, the one you saw it, they were not in y equal form, can be graphed using what we call intercepts. There are 2 intercepts. One is called the x-intercept, the other one is the y-intercept. Okay, so let's see some example here. this is the classic linear example, and you notice we have an x-intercept. This is the x-axis. This is the x-intercept, and an y-intercept. Okay, the x-intercept is on the x-axis, the y-intercept is on the y-axis. Well, notice I said here the graph of a linear equation has at most one x-intercept and one y-intercept. In this case, we see both. In this case, when you have a horizontal line, we have only the y-intercept. And in this case, when you have a vertical line, we have only the x-intercept. So be aware, not all the time you're going to have both intercept, x and y-intercept. Most of the time you do. And I'm going to show you now how to graph a linear equation using intercept. This is the last example in this lesson. And we have this one, graph 2x minus 5y equals 0. So you want to make x equal 0. If you remember, that's one of the things I did in the previous problems. So I'm going to have 2 times 0 minus 5y equals 10. 2 times 0 is 0, so we have only negative 5y equals 10. So this method is very good because right away you can see, hey, this guy is gone. So I have only negative 5y equals 10. Divide by negative 5. And you end up very fast to a value for y, which is negative 2. So this intercept is 0 and negative 2. I'll suggest you to write it like that. And this one, by the way, is the y-intercept. When x is 0, you get the y-intercept. Okay, let me write it here. Now let's move to the x-intercept. And the x-intercept, you get it by making y equals 0. Very similar of the x-intercept, just make the y. And some of you may say that the only thing left is 2x, and that's correct, but let's see that. 2x minus 5 times 0 equals 10. 5 times 0 is 0, so like I said, only 2x equals 10. Divide by 2, x equals 5. And sometimes you can do this math mentally, especially if the numbers are friendly, like in this case. The intercept is, be careful here, the x is 5, the y is 0, it's 5 and 0. So I can plot this point, and like I said, you don't need any other point. We have 2 points, we can graph the line, and that's it. This is the graph of the linear equation 2x minus 5y equals 10. If you enjoyed this lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.